Here we go. We have a question. Final array state after k multiplication part 2. So you have given an integer array nums, an integer k and an integer multiplier. You need to perform k operations on num. In each operation, we need to find the minimum value x in the array. If there are multiple occurrences of minimum value, then we have to select the first occurrence, and after selecting the element, we have to replace the selected value with x multiply multiplier. So after this, we have to do this for k times and apply modulus operation to every value in an array. After this, we have to return an integer array denoting the final state of the input array. After performing all k operations, then applying the modulus. Suppose we have this, and after one operation, this is the minimum element, and we will multiply with the multiplier. So we have this array, and then we select the minimum value. So we have two minimum values, but here we have to select the first occurrence. So after selecting the first occurrence, we will multiply with the multiplier. For the third operation, we will again select the minimum element and multiply with multiplier. Then select the minimum element, multiply with multiplier. Then select the minimum element, this with multiplier. So we have to do this for 5 times. After 5 times, this is the resultant array, and then we return. So this is the output. So if we have this array, and um, we have to do this for k time, we have to do this for 2 times and multiply with this value. So we have this value, minimum is this, then we multiply, then actually this is the array, and after one operation, this is the minimum array, we will select this element and multiply with the multiplier. This is the minimum element, then we multiply it. So we have this array as our resultant after two operations, and we need to apply modulus operation. So that's the resultant. So now let's mm, build the approach. So I have a picture here. Suppose this is our array 213. 213 is our array. So 213. So we need to find the point after which the array repeat itself at a fixed interval. Suppose this is our input array, and we find the minimum element, then it will become 2. Then we again find the minimum element, so it will become 4. We again find the minimum element, it will become 4 each time. So this is our initial array. It's time to select the maximum element in our initial array. So if we multiply this, multiply with the multiplier, here multiplier is 2, so it will become 6. Now this element change, now this element change, now this element change. After this element change, this element will change, this element will change. After this element will change, this element will change, then this, then this, then this, then this. So you got my point. So what I'm saying is, after a point, after a point, the array repeat itself, means every element in the array multiplies with the multiplier. So here the k is 4, here the k is 4. After 4, at every n steps, we got a array, we got a array where all elements are given by current element multiply by multiplier. So after this point, all the element in the array multiplies with the multiplier. So I think there's a mistake in this picture, because uh, why mistake, because this I think this is the break point. So after this element will change, then this element will change, then this element will change. So I think the point is 1 in this case. So we need to find the point. So if you look at the constraint, here the k is very large, so we cannot use a priority queue and do operation for k times. We have to somehow reduce the k. So by looking at this picture and analyzing that the array repeat itself at some point, at a particular moment the array repeat itself, so that's how we will decrease our k, so in this case the k is 4. Why? Because at this moment our mac in the initial array, in our initial array, so the maximum element is 3. So if our maximum element is multiplied, so that's the trigger point. From then all the elements multiplied by multiplier, so we need to find that point. So by how do we find that point? So we will first find the minimum element, maximum element. In this case maximum element is 3. That's pretty easy. And we have to use priority queue. So on the priority queue we have a value and we have index. So I will add every element with its index in my priority queue. So this priority queue is a minimum priority queue, and it will give me first this element. So then I will multiply this element. I have this element, I have this array, this element. So we will multiply it with the multiplier. So let's take this sample test case. So 2 1 3 5 6, 2 1 3, then 5, and then 6. So in my priority queue I have element 2 with its index 0, then a 1 element with index 1, 3 element with index 2, then 5 element with index 3, then 6 element with index 4. And here multiplier is 2, and we need to do this for, let's suppose a very big time, uh, so many times. Let's take 1 6 5 6 2 6. Let's take a random value. So first we have this value 1, so I will take out this value. Before this we need to find our maximum element. So here maximum element is 6. We will iterate in this and find our maximum element. So then it's time to pick the smaller element. So we'll pick the smaller element and multiply it with the multiplier. So we will multiply it. So the element becomes 2 in this case, and its index is 1. So as we can see, this we have we have another element with a smaller index, so it occurs first. So priority queue will prioritize this value first. So then we need to multiply this value. So if we multiply this value, we have 4 and its index is 0. Then we have this. So we will again multiply this value, and its index is 1 and value is 4. We will pop out this value, and as we are doing a operation, I will subtract 1 from a k, because we are doing an operation. So next we have 6. So its index is 2, value is 3, and index is 2. Then it's time to pop out this value. So if I pop out this value, we have this 8, which is greater than our maximum value. If I multiply, so that's, this is a trigger point. If I multiply my priority queue, peak element, if I multiply with multiplier, it becomes greater than maximum element. It becomes greater than the maximum element. This is multiplier. So if I do this, so it will become the greatest value. So this is the trigger point here. So like in this case, first we have this value, so this is fine. Next we have this value, so if I multiply with the multiplier, it becomes 4. So it becomes 4, and this is the trigger point. So after this multiplies, then this multiplies, then this multiplies. So this is the trigger point, and we need to find out the trigger point. So after finding the out the trigger point, we know this is the point. So we know the point. So we have this index, and let's suppose we need to do this for 16 times. 16 times, and we have um, done the operation for only one time, and after one time we find out the trigger point, and we have 15 operations left. Then what we do is, if I have to find how many times every element have to be multiplied. So here this is 3. So after every 3 times the element repeats, or what we can do is, we have 15 elements left, and for every element 1, 2 and 3, so its length is 3. So for 3, so we have a value 5. So 1, 2, 3, 4, then 5. So 5 times every element, 5 times every element have to be multiplied. Suppose let's take 17. So I have done one operation, and 16 element is left. 16 operations is left. So 16 by 2 is 5. So 5 times every element 5 times have to be multiplied by multiplier. So here multiplier is 2, and we need to multiply current element means nums of I have to multiply, with 5 times. So 2 raised to power 5, 5 times I have to multiply the current element with 2. So why not for every element I have to do this task. So why not pre-compute this? So I will pre-compute this. So let's say a raised to power b with some modulus operation. So let's say this is a power. So power, for every element I have to multiply with a variable power. So after finding out this, I have a modulus remain, because of 5 times I have done this task, but one more time I have to do. So I will find the modulus. Let me erase this. So 16 by 5 means 1. So one more, so I have to multiply the minimum element with I have to find the minimum element, and have to do the task for the remainder times. I have done this for 5 times, and for this element I have to do I have to multiply with a time plus 1. So for this we have to do this for 5 times only, because this is our answer, and for the remainder elements we have some remainder. So for the remainder elements I have to multiply with one more time. I have to multiply the current element, or the minimum element, actually minimum element, with the multiplier. So in this case this is our trigger point, and if I actually I don't need to add this, because this is our trigger point, and then I think I have done this for 4 times, and now we have this value remain. We have this value here, its length is 5. So we will take out with 5. So we will mod with 5. So first we will divide with 5, because here its length is 5. So we have to multiply with, suppose, x times. So it is k divide its length, and for k divide k modulus n, we have remainder operations. For remainder operations, we will find the minimum element, we will find the minimum element. So we have to multiply the minimum element for just one more time. For this value we have to do this for time plus 1 times. We have to multiply with time plus 1 times, and for this value we have to do the task for only time times. So for power times, so we have to do this for 5 times, and we have to multiply with this for 6 times, and for every element we have to do this for only 5 times. So let's code this. So don't forget to apply modulus. Then we have a power function. It represent a raised to power b. So first we need to compute this. So I hope you are familiar how to do this fastly, because I will not take much time here. So if power is odd, then we will just multiply a. So we will take out a, and its power is decreased by 1. And if the power is even, then we will multiply, then we multiply a with a, and is power we have to divide by 2. So this is the multiply operation a. So we have two values a and b, and we need to multiply a then b and apply modulus operation. So we need to do this. Next, if multiplier is 1, then just return your initial array. Then we have a priority queue and its comparator. If value is equal, for on the zeroth index I am storing my value, and on one index I am storing the index. So if value is equal, sort it with index. If it is not equal, we have to sort it with value. Next, we are iterating. So element, then its index. Then we need to find the maximum value. So here I am finding the maximum value. So then n is, so this is the crucial point. We have to either k is greater than 0, or as I have discussed, if multiplier is multiplied with the current element. So this is the current element. So this is the check for, is maximum still the greatest value, is max still the greatest value after multiplying current value with multiplier. So we need to do this. So this multiplier is integer, so either we can convert into long, and this value is also integer, so either we can convert this into long. So what I did is I put this pq value on the other side. So now we have this check. So after doing this, I am removing the minimum value. So we have 0th index value, and on one index I have index. So then we need to put it after multiplying. So for the 0th value, we need to typecast into integer and multiply with value and multiplier. Multiplier is a function here. So first we need to do is, we will take out the minimum value and multiply it with the multiplier till a trigger point occurs. And on second index, same as it is the index. So till the trigger point node executed, we will do this task. So this is the trigger point here. If if we multiply the current element with the multiplier, if it become greater than the maximum value, greater than the initial array maximum value, then this is the trigger point, and we will go out of this while loop. And don't forget to decrease your k. Then um, we need to multiply with some times. So this is the times k divide every element. So this is the length, and some remainder times. So I have a variable first. It means a raised to power b. So this is the multiplier. Multiplier raised to power times. and one more time for the remaining elements. So that's why I have a variable second, and we need to do the operation for the remaining elements, for the remaining operation. After finding the trigger point, do we need to find the minimum element and multiply with the multiplier for just one more time. So that's why we need to do this for one more time. So variable, then we have a priority queue. Till priority queue is not empty, take out value and its index, then reinitialize your initial array, with multiplying value. This is the value, this is the function mul, multiplication, and we need to multiply every element. If our remainder is greater than 0, if our remainder is greater than 0, we will multiply with one more time. So we will multiply with second, and at the end just return your nums. Let's submit this. In this code, if you guys have any doubts, feel free to ask in the comment section. And we have successfully submitted this code with faster than 100%. So that's how this solution works. Thank you all for watching.